So welcome to the Educator Internship Program and Academy. First of all, I introduce myself. My name is Kumar and I have qualified CSIR NET JRF exam in mathematics in 2018 and I have completed my PhD from Motilal Nehru National Institute of Technology and I have 5 years teaching experience in this exam, which is CSIR NET mathematics and I will cover CSIR NET Mathematical Science for 2 months with 100 hours of the content plan. So in this plan, I will cover whole syllabus of the CSIR NET CRF exam, and I have the best tricks for solving the questions. I have more and more counter examples uh, for removing the wrong options in multiple types of the questions, and I have more formulas and more statements and theorems for selecting the right options in a multiple type of the questions. So in first unit, I will cover analysis part. So in analysis part, I will cover real analysis, which is the most important topic of the mathematics. So real analysis cover the net exams very much. So in the first part, I will cover elementary set theory, finite, countable, and uncountable sets, real number systems, Archimedean properties, supremum and infimum. Now, in second portion, I will cover sequence and series, different types of sequence and series, convergence, limit supremum, limit infimum, and so on. After that, I will cover Bolzano-Weierstrass theorem, Hein-Borel theorem, continuity, uniform continuity, differentiability, mean value theorem, generalized mean value theorem, and so on. In fourth part of this unit, I will cover sequence and series of the functions, which is mainly uniform convergence. In this part, I will cover Dirichlet test, Abel's test, WM test, and so on. In fifth part of this is Riemann sums and Riemann integral, improper integral. Okay. So in whole of the unit, I will divide it in fifth part, 5 parts, and mostly I will take 15 lectures of this unit. Okay. So I will take 15 lectures of this unit, 15 to 20 lectures of this unit, so that I will cover the whole syllabus of the real analysis of the CSIR NET JRF exam. Okay. Now I will move to the linear algebra, which is the unit one part. Unit 1, there is a real analysis and linear algebra. So in linear algebra part, I will cover vector spaces, subspaces, linear dependence, basis, dimension, algebra of linear transforming. Okay. So vector spaces, there are more and more complicated things such as basis, dimensions, subspaces, counting of the subspaces, basis, dimension, etc. So in first part, I will cover the elementary things. In second part, I will cover algebra of the matrices, rank, determinant of the matrices, linear equations, and how we solve the linear equations with the help of the rank of the matrices and an analysis of the solution. Analysis of the solution. Which type of the solutions exist? Which types of the equations exist? Finite, infinite, and many more. In third part, I will cover the eigenvalues and eigenvectors, Kelly-Hamilton theorem, continuity, uniform continuity, differentiability, and mean value theorem. Okay. So eigenvalues and eigenvectors is very important part in the linear algebra. In fourth part, I will cover matrix representation of linear transformation, change of basis, canonical forms, diagonal forms, triangular forms. Okay. Fifth part is a very important part of the net exams, inner product spaces and orthonormal. This means Graham studied orthogonal processes of finding orthogonal basis. In sixth part, I will cover the quadratic forms, the reduction and classification of the quadratic forms. So, for this, I will also take the 15 lectures, 20 lectures, so that I will cover the whole part of the linear algebra. Now, this is a unit 3 part, which is a complex analysis. So, algebra of complex numbers, the complex plane, polynomials, power, series, transcendental functions such as exponential, trigonometric, hyperbolic functions. In first part, basically in first part I will cover the complex analysis part, its basic definitions, and algebra of the complex analysis means addition of the complex numbers, multiplication of the complex numbers. In second part, I will cover analytic functions, CR equations, which is Cauchy-Riemann equation. After that, in third part, I will cover the contours integral, Cauchy's theorem, Cauchy's integral formula, maximum modulus principle for lemma and open map. In fourth part, matrix representation of linear transformations, change of basis, canonical forms, diagonal forms, triangular forms, and Jordan forms. In fifth part, I will cover Taylor series, Lorentz series, and calculus of residue, which is a very important topic of this program. After that, I will cover the conformal mapping, Mobius transformations, and many more. And on this basis, I will take 20 lectures. Okay. So if I will take 20 lectures, and I will cover also the previous year questions of Harlan, previous year questions. Okay. Now we move the algebra part, which is very important. So first of algebra is divided into 1, 2, 3, 4, and 5 parts. So in algebra, I will cover the group, different types of the group, okay, and rings. So fundamental theorem of arithmetic, Euler's function, congruence, Chinese remainder theorem, and one more. Groups, subgroups, normal groups, cyclic groups, permutation, Taylor's theorem, and many more. In fourth part, I will cover rings, ideals, prime and maximal ideals, quotient rings, unique factorization domain. In fifth part, there is some definitions of topology, basis, set, subset, limit, accumulation, limit point, and many more. So this part will also cover by 20 lectures. I will cover in 20 lectures algebra part. Now, I will cover the applied mathematics part, which is ODE, applied mathematics, and it is coming in unit 4 of CSIR NET exam. So in this unit, I will cover existence and uniqueness of solutions of initial value problems of first order for the differential equation, in which I will cover the Picard's theorem and ellipsis conditions. SCSIT ellipsis conditions. And in the second part, I will cover a general theory of homogeneous and non-homogeneous linear code variation of parameters, sturm Liouville boundary value problem, and Green's theorem. So this is my lecture plan, and I will cover this whole syllabus, and I will also take what this is 20 lectures. So I will cover almost 5 parts, and I will take 20 lectures for you. Okay. So thank you very much for giving me this golden opportunity, and I want to join this amazing platform for exploring myself and giving some knowledge to the students of the unacademic. Thank you very much.